Children, today in third chapter, Understanding Quadrilaterals, we are going to study its basics, that is, what is a curve and their types, definition of a polygon, classification of polygons on the basis of number of sides or vertices, diagonals of a polygon, interior and exterior of a curve, concave and convex polygon, regular and irregular polygon, and the sum of interior angles of a regular polygon. So let us first discuss what is a plane curve. A plane curve is a curve that lies in a single plane or a plane surface like paper. Means a curve which you can draw on a paper or you can draw on a plane, means that lies on a plane. Now these plane curve may be closed or open. Closed भी हो सकते हैं, open भी हो सकते हैं. Like here we have drawn few curves. Out of these curves, the first four curves, they are closed curve, and the last three curves, they are open from the top. And these closed curves can further be categorized as simple or complex. Like this curve is a simple curve because it does not cross itself. A simple curve means a curve which does not cross itself. This curve, second one, is a complex curve because it crosses itself at this point. Similarly, in these figures, the first one is a closed curve, but it is not a simple curve. It crosses at this point. The second one is closed curve and it is simple also because it is not crossing itself at any point. Next comes the definition of a polygon. Polygon is a simple closed curve that is made up of only line segments, means a simple and closed curve which is made up of, जो केवल line segment से बना है, then that simple and closed curve is called a polygon. Like in this figure, first figure, it is a closed curve. It is simple also because it does not cross itself, and it is made up of line segments. So it is a polygon. Similarly, the second and third curve, they are closed and they are simple also because they are not crossing itself. So they are also polygons. The fourth one, this curve, it is made up of line segments, but it is neither simple nor closed because it is not simple because it crosses at this point, and it is not closed, it is open from this end, so it is not a polygon. This one is also not a polygon because it is not simple, it crosses itself. This last one is also open curve, so it is not a polygon. Now these polygons can be classified on the basis of its number of vertices or sides. Polygon में कितने sides या vertices हैं उसके accordingly polygon का naming किया जाता है, उनका classification किया जाता है. जैसे if a polygon is having 3 sides, then it is called a triangle, like this figure. If it is having 4 sides, it is called a quadrilateral. A polygon of 5 sides is called a pentagon. A polygon of 6 sides is called a hexagon. And a polygon of 7 sides is called heptagon. A polygon of 8 sides is called a octagon. Now we will discuss about the diagonals of a polygon. A diagonal is a line segment connecting two non-consecutive vertices of a polygon. अगर हम किसी पॉलीगन की नॉन कॉन्जिक्यूटिव या नॉन एडजेसेंट भी कह सकते हैं वर्टिसेस को लाइन सेगमेंट से ज्वाइन करते हैं then that line segment is called its diagonal. Like in this rectangle PQRS, when you join P with R, it will give you a diagonal because for the point P, only R is its non-adjacent vertex. Q and S, they are adjacent to P. So we will join P with R to form a diagonal. Similarly, Q के adjacent R और P है, तो इसको छोड़ देंगे and you have to join Q with S, which is non-adjacent to it, to form its diagonal. It means the rectangle is having two diagonals. In a pentagon, we can have 5 diagonals: AD, AC, BE, BD, CE. Because CA is already we have discussed. AC or CA means the same. Now, interior and exterior of a closed curve. The part which is inside the boundary of a closed curve is called its interior, and the part which is outside the boundary of the closed curve, it is called its exterior. Next comes about convex and concave polygons. Polygons are also categorized in another way in two categories: convex and concave polygons. Now, what is a convex polygon? Convex polygon is a polygon which have no portions of their diagonals in their exterior or any line segment. You can say any line segment joining any two different points in the interior of the polygon lies wholly in the interior of it. Means अगर किसी पॉलीगन के सभी डायगोनल्स उसकी इंटीरियर में ही लाई कर रहे हैं, किसी भी डायगोनल पॉलीगन के किसी भी डायगोनल का पार्ट एक्सटीरियर में लाई नहीं करता है पॉलीगन के, then that polygon is called a convex polygon. और हमारे पास दूसरा तरीका भी है कॉन्वेक्स पॉलीगन को चेक करने का कि अगर हम उस पॉलीगन के इंटीरियर में कोई दो पॉइंट्स लेते हैं और उनको ज्वाइन करते हैं तो वो लाइन सेगमेंट अगर पॉलीगन के इंटीरियर में लाई करती है then it is called a convex polygon. Means if you are taking any two points in the interior of a polygon and join them, if it is lying completely inside it, then it is a convex polygon, otherwise it is a concave polygon. Like in this figure, all these are convex polygons because if you take any two points anywhere in the interior of the polygon, then that line segment will completely lie inside it. But these four are not convex polygon because if you draw a line segment joining two points, one at this point and another at this point, and if you join them then some portion of it will be lying out in the exterior of it. Similarly here and similarly here. Now next comes the definition of regular and irregular polygons. Regular polygon means which is equiangular and equilateral. Equi means equal, angular means angle. So if a polygon is having all the angles and equilateral means all the sides equal, then it is called a regular polygon. Means अगर किसी polygon की सभी sides और सभी angles equal हैं, then we call it is a regular polygon, otherwise it is a irregular polygon. For example, in a square, all the sides they are equal and all the angles are also of equal measure. So square is a regular polygon. But in a rectangle, we have all the angles equal, means it is equiangular. But all the sides they are not equal, that is it is not equilateral. So rectangle is not a regular polygon. So the another example of a regular polygon is equilateral triangle. In equilateral triangle, all the sides they are equal and all the angles are also equal, they are of 60 degree. And another example of irregular polygon is a right triangle. Here all the angles will not be equal. This is 90 degree and these two will be your acute angles. This pentagon is also irregular because here these two angles they are of 90 degree and the upper one it is acute angle. These two angles they are obtuse angle, so it is irregular polygon. So these last three are irregular polygon and the first two they are regular polygon. Now let us identify the type of curves in these figures. Here we have few figures. We have to identify the simple curve from them. Simple curve means the curve which is not crossing itself. So the first one, second one, fifth one, sixth one, seventh one, they are all simple curves. And simple closed curve, all these they are closed also. So the simple closed curves are also 1, 2, 5, 6 and 7. Next one is polygon. Polygon means a line segment that is made up of only line segment. A closed simple closed curve that is made up of only line segments. So only first and second one they are simple and closed curve and made up of line segments. So these two they are polygons. Out of these two, the second one is convex polygon because its both the diagonals will lie completely in its interior. The first one it's not convex polygon, it is concave polygon because if you take one point at this here and one is here, a part of the line segment will be lying outside its interior. Now next topic is our to derive the formula for the sum of interior angles of a regular polygon. किसी भी रेगुलर पॉलीगन की इंटीरियर एंगल्स का सम क्या होता है, इसको आइडेंटिफाई करेंगे हम. Here we are given few figures. The first one is a triangle. In this triangle, it is having three sides, and we know that the sum of the three sides of a triangle, three angles of a triangle is 180 degree. It is a The next one is a quadrilateral. If we draw one diagonal, then this quadrilateral is divided into two triangles, and since the sum of three angles of one triangle is 180 degree, so the sum of the angles of both the triangles will be 2 multiplied by 180 degree. If we want to have a correlation of this 2 with the number of sides 4 of this polygon, then we can write 2 as 4 minus 2 multiplied by 180. In the next figure, we have a pentagon. If we draw two diagonals of it, then this pentagon is divided into three triangles. And so the sum of interior angles of this pentagon will be 3 multiplied by 180, because the sum of angles of a triangle is 180 degree, and we have three triangles here, so the sum will be 3 multiplied by 180. But we have to have a correlation with its number of sides. So this 3 can be written as 5 minus 2. Similarly, in the last figure, we have a hexagon. If we draw three diagonals of it, it is divided into four triangles, and the sum of each angles of each triangle is 180 degree. So the sum of all the angles of this hexagon will be 4 multiplied by 180 degree. And to have a relation with its number of sides, we can write 4 as 6 minus 2 multiplied by 180 degree. So if we observe all these sums, we see that the variation is only at this point. Here we have 4, here we have 5, here we have 6. The remaining terms, they are same. So 4 means here it is shows its number of sides. Similarly, 5 shows its number of sides, and 6 shows the number of sides in the last figure. So if a polygon is having n sides, then the sum of its interior angles will be n minus 2 multiplied by 180 degree. Now, if it is having 7 sides, then the sum of its interior angles will be 7 minus 2 multiplied by 180 degree, because n will be replaced by 7. So it becomes 5 multiplied by 180, that is 900. If it is having 8 sides, then the angle sum will be equal to 8 minus 2 and will be replaced by 8. So it becomes 8 minus 2 multiplied by 180 degree, that is 6 multiplied by 180 degree, 1080 degree. Similarly, if the polygon is having 10 sides, then n will be replaced by 10. So the sum of interior angles will be 10 minus 2 multiplied by 180 degree, that is 8 multiplied by 180 degree. So it becomes 1440 degree. That's all. Have a nice day.